We've arrived at the velocity and the displacement for an object experiencing uniformly accelerated motion. Now let's answer the following questions. First of all, when is the object at its highest point? To do so, let's recall that from its initial position and its initial velocity, that object may be going upwards and then coming back down again. What is special about the time at which the object reaches its highest point? The body's going upwards, turns around and comes back down. So right at this highest point, the velocity at that time will be 0. So we can answer this question by solving for t in the equation v of t equals 0. Now, directly using our result here, we isolate t, and so we can rewrite this as minus v0 equals minus gt. Solving for t, we get t equals minus v0 over minus g, which is simply v0 over g. A second question we're going to ask is, when does the object hit the ground? We're going to assume that the ground is the height y equals 0. And therefore, to answer this, what we have to do is solve for t in the equation y of t equals 0. In other words, we have to set all of this equals 0 and isolate t. We're going to multiply each term here by -2, which will give us a g t squared minus 2 v0t minus 2 y0 equals 0. Now we can use the quadratic formula, and so we take this term and reverse its sign, then add plus or minus the square root of this squared, 4 v0 squared, minus 4 times a minus 2 y0g inside, and that whole thing is divided by twice this. Now this can get simplified a little bit, so this will be 2 v0. We'll keep the plus 4 v0 squared. Here we'll have a plus 8 y0g all over 2g. We can take out a factor of 4 from here, and when we do so, this will become a 2, and a 2 will come out. Once that happens, we can cancel out these factors of 2. So after tidying up a little bit, what we have is v0 plus the square root of v0 squared plus 2 times y0g, and that whole thing is divided by g.